clock showing in the video is of a very fine long case clock by John Topping. It is an extremely rare example of the equation of time clock, with this calculation on an early 18th century long case clock. We are all aware of the passage of time, yet we cannot see it. Many inventors have tried to measure time, but it was not until the invention of the pendulum that considerably increased the accuracy of clocks, so that the calculation of the equation of time became very relevant to clocks. Before the advent of the long pendulum, in the early days, the clocks were very inaccurate, and so calculating the difference between solar and our time would have been of little consequence. The long pendulum was first invented by Christian Huygens, a Dutch scientist, in 1656. The oscillations of the pendulum reduced error to less than 1 minute a day, and eventually to less than 10 seconds per day. Peter Clare, a clockmaker in the 18th century who worked in Manchester, insisted his clocks were right and the sun was wrong. A memorial to him reads, "Here's the cottage of Peter, that cunning old fox, who kept the sun right by the time of his clocks." Many people might think Mr. Clare's observations foolhardy, but it would be folly to dismiss them. The clock pictured here by a maker called John Topping of London is a superb month duration walnut long case clock with a dial showing the equation of time. With these increasingly more accurate clocks, the difference called the equation of time became more relevant, and Mr. Clare was right to some degree. His clocks were more accurate than the sun. The equation of time refers to the difference between the sun's time and that shown by the clock. This varies up to 16 minutes per day during the year. Only on 4 days in the year is there no difference between the sun's time and the time shown by clocks. The days on which the clock and the sun should usually agree are the 15th of April, 15th of June, 31st of August and the 24th of December. Effectively, Peter Clare's clocks were more accurate than the sun. This is the result of the elliptical rotation of our planet. The clock by Topping, shown here, is one of the few clocks ever made showing this calculation on a year calendar. It lets the operator know just how many minutes less or more the clock's time is from the sun's time, effectively making it easy to set your clock in the 18th century by means of a sundial. This clock also has the special feature shown in the arch of a spherical moon, showing the true shape of the moon. This is accompanied with a tidal times indicator and rise and fall of the pendulum, making for changes of seconds to the timekeeping. It is housed in a superb, elegant burr walnut cabinet. The dial shows very fine quality chaptering and spandrels, inside quarter divisions, and the rare feature of sweep seconds hand. The clock strikes the hours on a single bell. Very few clockmakers ever had the talent to make such complex clocks, and only the finest clockmakers have examples to their work. These are very few and far between. Tompion, I believe, made 3 equation clocks. Topping, as listed here, made a few. Williamson, who made several equation clocks for Quare, and the maker Gregg. Clearly, very few are still surviving today. The complexity of this movement is mind-blowing.